Hello everyone, today is day 24 of solving a LeetCode problem every day, and today I'm going to be solving copy list with random pointer. So a linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Our job is to construct a deep copy of the list. So I'm just going to go over this diagram right here because I think this explains the problem much better than like reading all this. But essentially we're given a linked list such as this one, and our job is to create a brand new linked list that pretty much just copies this one. Now, what the problem is we can't use any of these nodes to create the new list. We need to create brand new nodes and basically match them up to this list. And the second problem is the random pointers in the new list can't point to nodes in the old list. They also have to point to the new nodes in the new list. They also can't point to like random nodes that you create. Like for example, if I were to replicate this list, and let's say I've already made the list, but now I'm just trying to fill out the random pointers. Random here points to, or this one points to null. This is a bad example, but for example, here random points to 7. In the new list, I can't have this random pointer point to like another node 7. It has to point to the 7 that's before the 13 in this list, if that makes any sense. Basically what I'm trying to say is the number of nodes in this, whatever the new construction that we're making is, has to match up to the number of nodes in this. You can't have extra nodes. But anyways, let's just get straight into solving this. So first of all, I'm going to create a dummy node. What I'm pretty much going to do is I'm going to split up this problem into two parts. So the first problem we're essentially trying to solve is replicating the list itself, like without the random pointers. And then the next problem we're going to solve is how to like create or fix up the random pointers in the new list pretty much. So the reason I set this to be negative 100,000 is because in the constraints, it tells us that the node value at it's either at minimum going to be negative 10,000 or it's going to be at most 10,000. So I'm making this to be negative 100,000 because this is a value outside of the values that we could possibly be given. So we can basically know that this is a dummy node. But anyways, it's not going to really matter in this question, but just in case I did it like that. The next thing I'm going to do is actually create the copy of the list. So we're going to have a current pointer, and current's going to point to head. Then I'm going to call this current new, which is going to point to the new list. So we're going to just point this to dummy. And then we're going to say while current. So while current is not null, what we're going to do is, let's see. So we want to replicate this list. So we have to first of all create a new node. And this node is going to have the value of the current node we're at from the old list. So pretty much what we're doing in this line is creating a new node that can match up to the current node that we're at from the old list. And then we're going to say current new dot next is equal to new node. And then we're just going to increment both. So current new is equal to current new dot next. So now current new is going to point to this new node. And then we're going to say current is equal to current dot next. Cool. So if I just print this out now, so if I say current new is equal to dummy, then I say while current new, I'm just gonna say, or let's say dummy dot next here because we want to start from the beginning of the list. So if I do this and run this code, okay, so it's infinitely looping because I forgot to increment this here. But let's just give it a second to do its thing. Wow, this is going for a while. I'd expect it to just stop at this point. Oh, output limit exceeded. Okay. Okay, so now we see we have 7, 13, 11, 10, and 1s, which matches up to the old list. So what we just did is we just created the new list. Except the only problem with this new list is the fact that these random pointers just aren't, like, they're all currently null. So we have to figure that out now. How can we get these random pointers to point to the correct nodes? So the way I'm going to do this is by using a hash map, and I'm going to call this hash map old to new. And essentially what the purpose of this hash map is going to be is that it's going to map all the old values to the new, it's going to map all the old nodes to the corresponding new nodes. So pretty much we're going to create it in here. So I'm going to say, we have our new node here. So we can just say old to new. And then we're going to say, let's see, current is equal to new node. So now if I just print old to new, I don't know why it's formatted like this, but we can see we pretty much have a dictionary where all the old nodes have now have references to the new nodes. And you guys will see why this is important in just a second. But what we're going to do next is reset these pointers. So I'm going to put current back to head, but now I'm going to put current new to dummy.next. Because what we're going to do now is we have the current node that we're at. So what we're going to do is from this current node, we're going to get the random node. And then from the random node, we can enter the random node into the hash map to grab the new node that was created in the new list. And then basically what we're going to do is just take this, whatever current new is, whatever the current node in the new list is, and we're going to set the random node for this to be whatever the output of that will be. So I guess one thing, so if I print head.random, okay, it's none, but so this is a bad example. But let's say I print head.next.random. It's a node. And this node, so if I go to old to new, this node right here matches up, or sorry, this node right here matches up to some node in the new list. So if I were to also print this, we can see here that these are two different references, just because if you look at the address right here, they're different addresses. So these are two different nodes, but this node right here is the random node for head.next in the old list. And this node right here that we're printing here is its corresponding, so this random node's corresponding node in the new list. So why I'm explaining that is because what we can do is say while current again, and then the first thing we're going to do is grab the random node from the current node that we're at, which from the old list. So we can say old random is equal to current.random. So that's number one. Next thing is we want to check if this random node is equal to none, because for some of these values, like for example, in this case right here, random points to null. So we don't need to do anything at that point. So we can say if not old random, and we just say, we just want to increment the 2 pointers. And then we just continue because we don't want to execute anything else. Otherwise, we know that we have some random node here. So what we want to do is now grab the corresponding node from the new linked list. We can call this new random, and we can say old to new, and then old random. So now over here, we grab the corresponding node from the new linked list that corresponds to this old random node right here. So now we have the new random node. So all we have to do is say current new dot random is equal to new random. And now we can just increment the pointers. Cool. So at this point, we can just return dummy.next because it's the new beginning of the linked list. So let's try running this, see if we messed anything up. Accepted, let's submit. And it's been submitted. So I hope that made sense. So essentially what we're doing is we get the old random node. So we have 2 pointers. So let's say we have a list such as like 1, 2, 3, or let me copy this test case right here. So we're going to have a list that looks like this one. And then current is going to point to here. Or we're going to have 2 lists, sorry. One's going to be like, one of them is all going to be null. Because this bottom right here, this is the new list. And the one on the top is the old list. So these are all initially going to be null. And then let's see. So we have a pointer. So our current is pointing to head, which is this node. And our current new is pointing to dummy.next. There is a dummy node right here, but I'm not going to include it because it doesn't really matter in this case. But this is our dummy.next. This is our current new. So here we can see that old random is equal to current.random. Current.random is just null. So we just increment these pointers and continue because this can stay as null. So now we're at these nodes. Now we see here that 13 has 0 as a random node. And where is 0? Where am I missing something? Seven, 13. Oh, okay. These are index based. So this is saying like the zero with indexed in the linked list. So this is a 0 right here. So it means that this node's random node is this one. So what we're doing here is we grab this random node, then we find its corresponding new node, which is this one right here, and then we just set this random value, we just now set it to this one. That's essentially what's happening here. But anyways, for time complexity, this is just going to be linear because we just have 2 while loops that iterate through the linked list. So we're iterating through the linked list twice, but it's linear time. And then space complexity is going to be linear too, just because we are creating a hash map that points these old nodes to the new nodes. So yeah, that's my solution for the day.